Hi, my name is Nick Baker, and I made The Urban Underdog, a 3D race car driving game where you go for your best time on randomly generated racetracks. In the game, you can customize your car color to any color you want. This will be saved in the browser's local storage. And you can generate an infinite number of random racetracks to play on. When you find a track you might want to keep for later, you can copy a code to the track and put it in a notepad or send it to your friends. And then you can put it right back into this text box and click input from track code. This will regenerate that same exact track. To develop this game, I had to learn a lot about 3D projections, Barycentric Coordinates, Rasterization, and how to actually create randomly generated racetracks. Here's what I learned. For 3D projections, we start with our camera in 3D space, and we have a point in 3D space. This point can represent the position of a game object or a vertex of a mesh. We then project that point onto the plane that is the display plane or the screen of the camera, which is aligned with the X and Y axes. We then shrink that point to the center of the image of the screen, depending on how far away it is from the camera or its Z value, and depending on the camera's field of view. This way, points that are farther away from the camera appear smaller, and objects that are closer to the camera appear larger. If the camera is rotated, then the plane will be offset. But instead of actually offsetting the plane, what we do is we rotate all of the points around the camera in the opposite direction, and then we do the same projection from there. Next, I would like to talk about barycentric coordinates. Barycentric coordinates represent a weighted average between three different values. So if we had point P on this triangle A, B, and C, and we wanted to find out how much it's weighted towards each point on the triangle, we would split up the larger triangle into smaller ones, link up the smaller triangles to the point that is opposite from them, and then figure out how much of the entire triangle each smaller triangle is taking up. For example, if the point P is on A, then little a takes up the entire triangle, meaning that the weight of A is 1, and the weight of B and C are 0. If point P is near the middle, then the weights are almost the same. Notice how these all add up to 1. If a point is off of the triangle, then its weights will all add up to be either greater than 1, or one of these weights will be negative. We can use this as a check to determine if a point is on or off of a triangle. We can use this check when rasterizing these triangles onto a bitmap image. First, we find the bounds of a triangle. That means we only need to check with the pixels that are within these bounds. Then we go through every pixel, determine its barycentric coordinates, and if they add up to be 1, then we know that it's within the triangle and should be colored in with that triangle's color. Finally, generating randomized racetracks. I follow a procedure that was written by Gustavo Maciel, and that starts by placing points at random positions on a 2D plane. Then you create a convex hull by following the Jarvis march algorithm. We start at the rightmost point, and we create a line to the next point in the array. If the next point is on the right side of that line, then we forget that line and create a new line. We keep doing that and comparing all of the points until we find the rightmost line. Then we do the same procedure on that point, and then we do the same procedure on the next point until we have looped all the way through until we got into the starting point. Then we can take this polygon, cut up some of the longer line segments, move those new points around by random amounts to create some indentation and variance in the shape. Then we extrude those points outward by random amounts to create some width for the track. And then we create a randomized height map, and we apply those heights to the points on the track. And then we finally create the mesh for the track. To end off the video, I'll show you more of the game in action. Thank you for watching.